You've highly lauded Elon and xAI's accomplishment in Memphis in building Colossus supercomputer, probably in record time in just 4 months. It's now at 200,000 GPUs and growing very quickly. Is there something that you could speak to that you understand about his approach that's instructive broadly to all the data center creators that enable that kind of accomplishment? His approach to engineering, his approach to the whole management of construction, everything.
First of all, Elon is deep in so many different topics, yet he's also a really good systems thinker.
Hmm.
And so he's able to think through multiple disciplines. And he obviously pushes things, questions everything, whether number one, is it necessary? Number two, does it have to be done this way? And number, does it have to take this long? And so he has the ability to question everything to the point where everything is down to its minimal amount that's necessary. No, you can't take anything else out. And yet the necessary capabilities of the product retains, and so he is as minimalist as you could possibly imagine, and he does it at a system scale. I also love the fact that he is represented. He is present at the point of action.
Mm-hmm.
He'll just go there. If there's a problem, he'll just go there and he'll show me the problem. When you do all of this in combination, you overcome a lot of previous, this is just the way we do it.
Mm-hmm.
I'm waiting for them. It's just everybody has a lot of excuses, and then the last thing is when you act personally with so much urgency, it causes everybody else to act with urgency. And every supplier has a lot of customers going on. Every supplier has a lot of projects going on, and he makes it his business that he's the top priority of everybody else's projects, and so he does that by demonstrating it.
Yeah, I've been in a bunch of those meetings. It's fun to watch because really not enough people ask the question like, okay, so can this be done a lot faster and how? Why does it have to take this long?
Yeah, right.
And then that becomes an engineering question often. And yes, I think when you get the ground truth of actually, I remember one of the times I was hanging out with him, he literally is going through the entire process of how to plug in cables into a rack. Was working with an engineer on the ground that's doing that task, and he's just trying to understand what does that process look like so it can be less error prone. And just building up that intuition from every single task involved in putting together the data center, you start to immediately get a sense at the detailed scale and at the broad system scale of where the inefficiencies are. And so you can make it more and more and more efficient. Plus you have the big hammer of being able to say, let's do it totally different.
Yeah,
and
that's
remove
right.
all possible blockers.
That's right.
Is there parallels in the NVIDIA Extreme Systems co-design approach that you see in the way Elon approaches systems engineering?
Well, first of all, co-design is a ultimate systems engineering problem.
Yeah.
And so we approach the work that we do from that principle. The other thing that we do, and this is a philosophy that a thought, a state of mind, I guess, a method that I started 30 years ago, and it's called the speed of light. The speed of light is not just about the speed. Speed of light is my shorthand for what's the limit of what physics can do. And so everything that we do is compared against the speed of light. Memory speed, math speed, power, cost, time, effort, number of people, manufacturing cycle time. And when you think about latency versus throughput, when you think about cost versus throughput, cost versus capacity, all of these things, you test against the speed of light to achieve all of these different constraints separately. And then when you consider it together, you have to make compromises, because a system that achieves extremely low latency versus a system that achieves very high throughput are architected fundamentally differently. But you want to know What's the speed of light of a system that achieves high throughput? What's the speed of light of a system that achieves low latency? And then when you think about the total system, you could make trade-offs. And so I force everybody to think about what the first principles, the limits, the physical limits for everything before we, you know, do anything, and we test everything against that. And so that's a good frame of mind. I don't love the other methods, which is continuous improvement.
Mhm.
The problem with continuous improvement, first of all, you should engineer something from first principles at the speed, with speed of light thinking, limited only by physical limits and physics limits. And after that, of course, you would improve it over time. But I don't like going into a problem and somebody says, hey, it takes 74 days to do this today, right now. And we can do it for you in 72 days. I'd rather strip it all back to zero and say, first of all, explain to me why it's 74 days in the first place. And let's think about what's possible today. And if I were to build it completely from scratch, how long would it take? Oftentimes you'd be surprised and might come to 6 days. Now the rest of the 6 days to 74 could be very well reasoned and compromises and, cost reductions and all kinds of different things. But at least you know what they are. And then now that you know that 6 days is possible, then the conversation from 74 to 6, surprisingly much more effective.